everyone, we're going to let b sub n be a sequence of positive numbers that converges to 1/2. Then we're going to determine if our series is absolutely convergent. So let's look and see what we have. The first thing I want to do is look at this cosine. If we let n equal 1, just for this piece, we're going to get -1. If we let n equal 2, we're going to get 1. If we let n equal 3, we're back to -1. N equal 4, we're back to 1. So we have this alternating series there. I can rewrite this, therefore, as n equals 1 to infinity. And I can write this part, cross this out, and write it as -1 to the nth power. And then we still have b sub n to the nth power divided by n. Now it's given that our b sub n is positive, and it's also, that's for n is greater than or equal to 1, given there. And it's also given that the limit as as n approaches infinity of b sub n, that equals 1/2. That's given here. All right, so starting with that, let's go ahead and use the ratio test to determine if our limit is less than 1. So we're going to have the limit as n approaches infinity of a sub n plus 1 divided by a sub n. All right, this equals, and we're taking this, everywhere there's an n, these three n's here, this is just the sequence. We're going to put n plus 1. So we're going to have absolute value, limit as n approaches infinity, absolute value of -1 to the n plus 1 power, then b sub n to the n plus 1 divided by n plus 1. And then we're going to divide by a sub n, which is the same as multiplying by the reciprocal. So this is going to be just times n divided by -1 to the nth power times b sub n to the nth power. All right, so there we have it. And now we can simplify this as, and let's look at this, see if I can squeeze this in. This part right here is just going to go to 1, -1. An absolute value of -1 is 1. Because basically what you have is -1 to the n plus 1. And then since we have the n here and we use the quotient property for exponents, that's going to be minus n. So we're just going to get 1 for this. All right, now this part here is going to give us b sub n plus 1, and then we're going to subtract n again. So that's just going to equal b sub n, because the n's cancel, or to the first power. All right, so let's write that out. We're going to get this equals the limit as n approaches infinity of b sub n, and then we had n divided by n plus 1. All right, so we can pull out b sub n, we already know is 1/2. So this is just going to be 1/2 times the limit as n approaches infinity, and this is 1 over n divided by 1 divided by n plus 1. So this is just going to equal 1/2 times 1, and then this equals 1/2, which is less than 1, so it converges. So our whole series, n equals 1 to infinity of b sub n to the nth power of cosine of n times pi divided by n is absolutely convergent. I'll just put absolutely here. Thank you. Have a nice day. Bye bye.